In this lesson we're going to look at how integration is used to work out the area trapped between a function and the x-axis. So when you're integrating a function, really what you're doing is you are splitting the area underneath the function and the x-axis into rectangles. Lots of different rectangles all the way back to the origin. And integration calculation, if you substitute a number into this, it will work out the area all the way back to 0. So if we're trying to integrate a function between two limits a and b, if we only want this strip here, not all the way back to 0, then if we integrate and substitute b into this, then we go all the way back to 0. If we substitute a into this, then we get the wee triangle here. So if we do a takeaway sum, basically, after substituting b into it and then a into it, we'll get what's left over, which is this strip that we're looking for in this case. So the integral of a to b, these are your limits, this is your upper and your lower limit with respect to x, is given by f of b, substituting b into the integral and then subtracting a and been substituted into the integral. Now when you do this, then you generate constants, but when you do the takeaway, the constants will cancel each other out. So you end up with no constant term, you just end up with an exact value for whatever the area is under the curve. That's why it's called a definite integral, because it has a numerical answer. So let's look at an example here. What we have to do is evaluate x squared with respect to x, and the limits are the upper limit 4 and the lower limits 2. So if we were to draw this, this is the area we're looking for here, under the x squared, between the curve and the x-axis, and between 2 and 4. So if you integrate and put the 4 in, that will get the area all the way back to 0. But then if we put the 2 in, that will give us this wee white bit, and then if we do a subtract, we'll get the area here. So firstly, we use this square bracket notation to integrate. So we integrate x squared, you add 1 to the power and divide, so that's going to be a third x cubed, and then we put our limits on the right hand side, so the upper limit at the top and the lower limit below. We then substitute the 4 in, so we've got a third of 4 cubed, and then you take away and you substitute the 2 into the same integration here. So if we can calculate this now, then we can work out the area under the curve here that we're asked for. So 4 times, do the power bit first, 4 times 4 is 16, times 4 is 64, so 64 over 3. There's a variety of ways of doing this. You could leave it as 64 over 3 and then take away 8 over 3 and then change it into a mixed number. I have done it differently here, but that would be absolutely fine. I've changed it to 21 1/3 here, and then I'm taking away 2 2/3. But I would actually say it would probably be easier to do 64 over 3, take away 8 over 3, which is going to give you 56 over 3, and then simplify that down to 18 2/3. Notice I put units squared in here, because we don't actually have a unit of centimetres or metres or anything, so we always put units squared at the end. We have to remember we're calculating an area. So this is really what's happening here. We're integrating between 3 and 2. You're integrating from 3 to 0, and then you're subtracting 2 to 0.